Lower your rage. Yeah. You're like a savage beast.
On 8 days, yeah.
Why not on 8 days?
Just, that's why you're doing
take advantage of the time you have in class. Like, don't just sit and watch. It doesn't do any good. Like, for calculus, there really is no reason to have an attendance policy. Because if you don't come, yeah. So take advantage of the time when you're in class. Learn to self-quiz. I'm going to try and use that word a lot this year. Learn to self-quiz, which means learn to really ask yourself, how did I get from one line to the next? Make sure you are mentally thinking of the rules that are being used as you're writing them, as you're kind of working through the problem. Does anyone have a question to that? Keep in mind that when I picked all these problems for the homework and the practice tests, I couldn't, I'm not giving you problems like the ones that are exactly on the test, but I find problems that have steps that are like steps that occur on the test. So anything that doesn't make sense, make sure you ask. Okay, cool. So we keep going. Do you have any questions there? Chad?
If I don't know exactly how to word this. Actually, no, I know. I got it. Yeah.
No worries. 2 points for Chad. Anybody else? You always get 2 points whenever I call on you if I don't remember to say that. Factor out the y prime.
So on the left side, you only want to factor out the y prime, right? Like,
Yeah, because the
could
whole,
others,
even though
but-
more things could be
Yeah.
factored out, that's a good observation. You could definitely factor out an x and a y as well,
Mhm.
but I don't want to because I'm trying to get the y prime.
Yeah.
Oh, good question. No, so if you they told me to find the value of y prime at a specific xy coordinate, 2, 1. So now I switch and do that. So y prime's value when x is equal to 2 and y is equal to 1 is going to be question. Please.
So I factored on the denominator out an x and a y. Is that okay?
Totally. Question 2 for Kelsey. No? Oh, pretty good.
Yeah, my only problem is I added I subtracted the two squares, one, so that's what I added.
Don't worry. You know, let's bring with them a different question. Go practically, Sarah, 14. The word arctangent means inverse tangent. Arcsine means inverse sine. Arc cosine means inverse cosine. So they're asking me to find the slope of the line tangent to that curve, which means I can find the slope of the line tangent to this function by finding the derivative of this function. And I use the inverse tangent rule. So we have a question from there. So keep going. So I have dy dx is equal to 4 divided by 1 plus 4x all squared. So we have a question there. And I'm supposed to find the value of the derivative when x is equal to 1/4. So I take dy over dx. This bar means at x equal 1/4. It'll be 4 divided by 1 plus parentheses 4 times 1/4 all squared. Y dx at x equal 1/4 is equal to 4 over 1 plus, this just becomes 1 squared, which is 1. Final result is 2.
Wait, can you set the bar once again? Thanks.
Yeah, bar just means at.
Yeah.
So all I'm saying is, this is the formula for finding the derivative or tangent slope of the function
Yeah.
that we had at the beginning at any x coordinate.
Yeah.
I want to find this derivative at
Okay.
an x value of 1/4. That's all. Question? Please.
Does it matter, I mean, on the HTTP test, if it's dy over dx or y prime?
Not really.
No.
Anyone else? Sarah?
Yeah.
You have a different question probably to the class. Well. Easily repaired. All right. We're done it. Okay, everyone in the room, please have this memorized for the test. Listen close to my words. If you're answering a question and you don't have graphs, use sign charts. It's a simple phrase, but people forget that. If you don't have if you're answering a question, you don't have a graph, really your best option is going to be a sign chart. They want me to figure out where F has a point of inflection. So Danica's chart's a great start. Helps if you draw Danica's chart correctly.
Yeah.
Great. I want everyone to just look at the board as I say this. Look at the board, please. Everyone look up. Everyone look up. Chad, look up for just a second. Okay, I've seen this mistake happen a lot, so I'm just trying to fix it now so it doesn't happen anymore. I need to figure out when F changes concavity, because that's where F will have any points of inflection. Should we one or two if that makes perfect sense? Just that single statement. I gotta find where F has a point of inflection, because we have to see where F changes concavity. 2 points for the room. We've never learned how to make what I would call an increasing, decreasing chart. We don't have the ability to make graphs unless you're really good at remembering previous classes, which is fine if you can, but if you can, we can't do an increasing, decreasing chart of F prime. We have to do sign charts. But a sign chart of F prime won't help. I'm trying to figure out when F changes concavity. So I need a sign chart of F double prime. Do one or two if that makes sense. Two more for the room. So they gave me F double prime, so I can go ahead and just make a sign chart of F double prime. They also gave me F double prime factored. So that was very helpful. Let's see, this is equal to 0 and x is 0. 3 and 6, so I need to spread these out a little bit. Okay, look at the board again, look at the board. Let me show you something where I've seen people make a lot of mistakes, is they say to themselves, okay, I need to have x equal 3 up here. They need to have x equals 6. Well, there's a fair amount of room, but there's still a little bit of risk that they might be too close together. When you have the values too close together, mistakes often occur. So I'm just going to fix that. Go like this instead. Put the 0 over here. Just make sure I have plenty of room. Question. So build the chart now. Now I can draw what F double prime is going to look like. anything to there that you'd like to talk about? Anything that didn't make sense that you're like, "No, I need to talk where that came from." Don't ever accept anything just on memory. Make sure you ask about it. Taking notes still, wait a second. Please.
So why on the f double prime, since there's like, so to the left of 0, right? X squared would be positive, all the rest would be negative. Wouldn't that make f double prime negative?
Let me say it back to you, then you'll see it.
All right.
So let's pick a value just to make it easier to talk about, say like -1.
Yeah.
So if x is equal to -1, this term will be
1.
good. And all we care about is the sign,
Yeah.
so positive. This term will be,
Negative.
and this term will be good. And that's reflected in the chart, positive, negative, negative, right? Those three terms multiply together. So you tell me what's a positive times
Oh, okay. Oh, okay. So
You
it's
see
2
it now?
negatives now.
Don't worry, it's a good question. Does that make sense?
Yes.
Awesome. Well, 3 for Landon. That's exactly what I want you doing in classes. Just when something doesn't make sense to you, just talk about it until it does. So, yeah, perfect. Then I would just write down the answer. I'd say at x equal 3 and 6. Let's see, f double prime changes from positive to negative and negative to positive. So at x equal 3 and 6, f will change concave up to concave down, and concave down to concave up. So x equal 3, 6 are inflection points. On out. I have a question. Please listen.
I thought if we did a sign chart for f prime, we're dropping that.
If we do a sign chart of f prime, we definitely can get a pretty good picture of f, because we can see when f goes up and down. Good memory, you're talking.
I don't know how, like, you do a double chart or two-line chart, and then you go
Oh. Everyone listen to this. Everyone listen. I would highly recommend against looking at an f double prime sign chart and trying to draw what f would look like. It's very difficult to simply go from, like, knowing that f is concave up. The trouble is this. If f is concave up, f could look like this. But f could also look like this, and f could also look like this. I don't know which of these three, because all I know is f is concave up. So if all I have is a sign chart of f double prime, I can tell that, in this region, when x is less than 0, f double prime is positive, so f will be concave up. But I don't know which kind of concave up. So I don't ever try to draw a graph of f from f double prime. That's one thing I want you to remember. You'll never try to draw a graph of f from f double prime. But I can answer questions about f from the f double prime sign chart. For example, this is going to help me. For x equals 0 and less, f double prime is positive. So what do you know about f for those same x coordinates? F is concave up. For x values, answer this one. So for x values from 0 to 3, f remains concave up. I'm not drawing a picture. I don't want to draw a picture. X equals 3 to 6, f is concave down. And then back to concave up. So this alone is enough to answer the question, which is where does F have inflection points? F has inflection points when the concavity of F changes. That's occurring at x equals 3 and x equals 6. I'm not sure I really answered your question at all.
No, that's.
You sure? Because it was a good question. Anything else? Cool. You know, to bring a question within the class, please. 26. Quick wake-up story. Okay, everyone, concentrate. Okay, 26 is not a hard problem, but it does have a lot of steps. So any step I take that doesn't make sense to you, you've got to ask me about it. I did it last period, so we'll save a little bit of time, but I'll give you as much time as you want to take notes. You always learn better if you're taking notes rather than just watching. And you learn the best by taking the time to write it down, think about what you wrote down, ask about it if necessary. They said the graph of F has exactly one point of inflection. They gave me a formula for F up here. Find the x-coordinate of this point. So it really is similar to something we've already done today. F will have a point of inflection when F double prime changes sign. So I need a sign chart of F double prime. They did give me a big head start because they gave me a formula for F prime. So I wrote down the formula for F prime, and I immediately said I've got to use the quotient rule to find F double prime. So that gets me to here. So make a note of that and ask about anything you want to ask about. I'll number the steps here. So here's 1, here's 2. So you have a question to there. It's a lot of writing, so I'll be patient. Just don't let me go too fast. I keep giving you these LN problems on the homework, on the practice test, because I know there's for sure 2, maybe 3 problems on the test that deal with LN. And I just want to give you as much help as I can. Once we've done the quotient rule, from here to here I use the ln rule. Well, I use the add subtract first. The derivative of 1 is going to be 0. The derivative of the ln of something is going to be 1 over the something, derivative of that something. This was pretty straightforward because the derivative of x squared is just 2x. Just another reminder, we're kind of in crunch time. The deadline for the test 2 stuff is Thursday. You'll take the next test on Wednesday. You decide you want to do corrections and or a retake for test 3. It's all got to be done by December 22nd because that's when the term ends. That's the last day before Christmas break. So,
Is there a line through that 2x or what?
oh, sorry, that's just the cursor.
Oh, okay, I thought that was-
Good question. No. Move that out of the way.
Did you keep the derivative of x for a reason? I don't know if you said that already, but
Right
on
here.
step 3.
The dx.
Yeah.
No, I wrote it down just to make sure no one misunderstood where it came from, but you don't have to write it. You could simply look here, Chad, and say the derivative of the ln of x is 1 over x, dx, so that's just 1 over x.
Yeah.
You don't have to write it. Ellen?
When going from 4 to 5, taking the x out, how are you able to take it, like, I don't know, you just.
The
want
factoring.
to take the x out?
So, and I'll actually pay some tickets for you to help me. A word I haven't been using very much this year, I'm going to try and use it more, it will help. When I look at this numerator, I am going to view the numerator as simply 2 terms that are being added, subtracted. 2 terms that are being subtracted. The first term is -1 times x, subtract this second term. So I see 2 terms. the first term can be viewed as two factors multiplied together, a -1 and an x. With me? The second term is really three factors. Somebody earned tickets, I'll give you three, being the three factors of the second term.
1 minus ln of x and then 2.
Perfect. So Lexi says 1 minus ln of x, 2 and x. So between this term and this term, the common factor is the x. So when I remove the x from this set of factors, from this term, I'm left with a -1. When I remove the x from these three factors, I'm left with these two factors.
So each part of the factor doesn't necessarily have to have it.
All you have to what you should always keep focusing on is, I first notice that I've got two or more terms, meaning two or more things adding together, and then identify within each term what's being multiplied to create the term. And so even though there's this weird 1 minus ln of x, doesn't matter at all, because I'm just treating that as a single factor. So this times 2 times x, I just pull out the x. It can be confusing, but the base idea is that when you look at a term, you're looking for a factor. The keyword is factor. Does that help?
Yeah.
Then I just distributed and kind of cleaned it up to get to number 8 there. Outstanding questions. Anyone else? Cool. I'm supposed to figure out where f has a point of inflection, so I have to make a sign chart. I cannot really factor the numerator anymore. So I've got to figure out what value of x will cause the numerator to equal 0. So I wrote that down. -3 plus 2 ln of x has got to equal 0. I do a little bit of algebra, I get to this point. Okay, right here, there's really two different ways you can go. Okay, you can remember this rule right here. The natural log of e to anything, well, that's actually a little bit hard because there's no e in this case.
Yeah.
So we're going to use this rule instead. I've given this to you in class before. If I've forgotten, please write it down, please memorize it. E to the ln of any value is just the value. You need this memorized. E to the ln of any value is just the value. So to solve for x, what I do is I simply take this half of the equation and I make this half an exponent of e. So, but if I do something to one side of the equation, I have to do it to the other. So make the other half of the equation also an exponent of e. That gets me to this point. Then e to the ln of x is just x. This side doesn't change, but I've now figured out the value of x. Pause there for any questions. Please.
Why do you want why do we want to figure out what x is equal to? Just again.
Got it. So I found f double prime.
Yeah.
I need to make a sign chart of f double prime so that I can use this idea right here, Chad.
Yeah.
You get there?
Yeah.
Perfect. Okay, to make the sign chart of f double prime, step 1 of any sign chart is identify the values of x which cause each factor of f double prime to equal 0.
Oh yeah.
So I wrote down I want this to become 0. So I do the algebra, figure out that that's an x value of e to the 3 halves. I want you to answer something for me just to make sure this makes sense. What is the natural, so I'm going to plug this back in just to test it. So let's write that down. So I say, let's see, -3 plus 2 natural log, I'm going to plug this in, e to the 3 halves. 2 points for Chad, somebody help me. Raise your hand, tell me, what is the natural log of e raised to the 3 halves power? Braden.
3 halves.
3 halves. Braden, what would 2 multiplied by 3 halves be?
3.
3. What's -3 plus 3? 0. So that's certainly the right value. That's what I was doing. Does that make sense?
Yeah.
Good. Please, Kelsey.
So why is x e to the 3 halves? Why wouldn't it just be 3 halves?
Say one more time.
So with the rule, it's e to l, like the e to the power of ln x, right? Equals the
me kind of label these, and you tell me kind of which step you're looking at. So we've got 1, 2, 3, 4, 5, and this was another thing I did.
So on 3, it shows that we want it to equal 3 halves, right?
We want the natural log of something to become 3 halves.
So on 4, is it saying that we want the, oh, okay, never mind. I just asked my own question.
Okay?
Yeah, I just got it. Okay.
Okay,
Sorry.
no worries, no, good question. Anybody else? You good?
So if it wasn't ln of x equal 3 halves, it's like dx to the 3 halves, then we just do ln thing to both sides.
Thank you. Here's what Oakley's remembering from a different class. If you had something like this, e to the x is equal to, I don't know, 5 or whatever,
Yeah.
and you want to find the value of x, you take the natural log of both sides. Because you have an identity I showed you on the last page. The natural log of e to anything is just anything. So now we know that x is equal to the natural log of 5. If we plugged it back in to test it, we have e to this is supposed to equal 5. But we just learned e to the ln of anything is just the anything, so that works.
Great.
Is that your question?
Yeah, I just wanted to know.
No, no. Somebody else. So we're back here. Is there any confusion to here? Anything to here that just doesn't feel like you're going to be able to remember it? Please, Jeff.
Step 3, 4.
No worries. Here's how I would remember step 3 to 4. First of all, you do have to just memorize these identities. Just get a flashcard and just keep going over and over so you don't forget them. And the second thing to remember is when I'm trying to get rid of the ln, I'm just going to take this and make it an exponent of e. I don't have a quicker way to get you to remember that other than that's what we do to solve the problem. And it's all because the e to the ln of x is just x. So some teachers will tell you that e undoes ln. Mr. Rucky likes to say that. That makes sense. It's their inverse functions of each other. That's how we get the x alone. That's a good question. That's not a very satisfying answer because I told you to just memorize a couple things, but there's not really a better way. Please.
So on the numerator of the f double prime, that's all one factor, right? Like the
Yeah, we're treating it as just the numerator factor because it doesn't really factor easily anymore. So, anybody else? So now for my sign chart, here's where Chad's at. I have the numerator factor and the denominator factor of f double prime. I know that when x, look here, x is equal to e to the 3 halves, we just proved that this will be equal to 0. I have to find a value of x that is less than e to the 3 halves. Someone last period said, well, why not e to the first? This is e to the 1.5, so e to the first is less. Just say it out loud, please. What is the natural log of e? 1. Louder.
1.
1. So 2 times 1 is?
2.
2. Negative 3 plus 2 is? Negative 1. So these are all negative. I have a question about that. We had to find a value of x that's larger than e to the 3 halves. Someone last period suggested e squared. The natural log of e squared is, say it, 2. 2 times 2 is? 4. Plus negative 3. 4. That's why those are positive. The x squared factor, x cubed factor is always positive because we're only dealing with positive values of x. Please help.
Isn't x cubed 0 is 0?
Absolutely. The only reason I didn't write it down is they told me up at the beginning to only worry about values of x that are larger than 0. But certainly perfectly correct, Ellie. This would make this undefined. That's why they said don't worry about it, because you get an undefined value. What else? So from that, I can figure out where f has an inflection point, and this is my answer. different question from the gold packet folder.
So, agree with the free response as that's the.
Oh, good question, hopefully. Everyone look up. I gave you some free response questions on the homework and also some free response questions in the practice test. One to kind of just get you used to what a free response looks like. More importantly, I was looking for some problems that would better prepare you for the kind of things you're going to encounter on the test on December 7th. And I just couldn't find enough multiple choice questions that did that. So there actually are only 25 multiple choice questions on the test. There are no free response questions. So that's not new. I just couldn't find enough multiple choice. So I gave you some free response for extra practice, that's all. Please don't. And as always, I'll keep adding problems to this file as different classes ask for different problems. And then tomorrow I'll post it. You can look at it if it has something that will help you. So. First thing that this chart would help. So I have G, G prime, G double prime. Let's see, increasing, decreasing. They tell me that G prime and G double prime are both greater than 0. So I can circle these two rows on the chart. Look, everyone focus on this I, please. You should have a flashcard from Unit 1 that says something like this. If the derivative of a function is increasing, meaning in this case G prime is increasing, then I know that every single tangent slope of G will be increasing. Like as I look at G, I'm going to see a pattern where from tangent slope to tangent slope, those values increase. Every secant will increase. We'll have an increasing pattern. And also, if I go tangent to secant, I see an increasing pattern. That little statement right there is going to unlock like 2 or 3 problems on the test. Just paying attention to that alone. So then they tell us, let's see, we have G of 4 is 12, G of 5 is 18, go find G of 6. So I draw a picture. I've got 4, 12. I've got 5, 18. And I've got, I don't know what 6 is. It says 6, 15. So that would put 6 over here. Right here, 6, 15. Someone look at Danica's chart and just tell me why this cannot possibly be a value for G of 6. For him. All who know, please, I'll pay everybody. Look at Danica's chart and tell me why this point red cannot possibly be the value for G of 6. Look at Danica's chart. Just come up with a reason. For Derek? It says G prime, or the slope of G should always be increasing. So from here to here, the slope of G would be, well, that's actually kind of hard to say, to be honest. We've got to be careful with that. No, that's not too bad. Like from here to here, if I drew a secant slope, I don't know what the curve looks like, but I can find that secant slope. But Derek's on the right track. So that's secant slope. Somebody tell me how to find the secant slope between those points, please.
Would it just be 18 minus 12?
Over 5 minus 4.
5 minus 4.
So that's a secant slope of 6. 2 points every time I call on someone. So that was Landon.
The secant slope, is that like, it's not instantaneous, it's the slope between 2 points?
Tangent slope is the instantaneous or slope at a point. Secant slope, slope between points.
Yeah, just clear enough.
So the secant slope here somebody else. No, sorry.
-3.
There you go. He just looks and says, from 18 to 15, the y value changes by 3 and it's going down, so it's got to be negative. The x value changed by 1, so that secant slope is -3. So here's what Derek noted. This secant slope is 6, the next secant slope is -3. That violates this requirement. It says as you go from secant slope to secant slope, those values must increase. It didn't happen. Questions, please?
I don't know if this is right, but could you say that that's concave down, or do you not know that?
We would know something for sure. If a secant slope goes from 6 and then the next secant slope is -3, it's certainly not always concave up.
Yeah.
Maybe it's concave down and concave up.
Yeah.
But certainly not just concave up. Well said. Anybody else? So that point doesn't work. Can somebody give me, I'll give you 3 points for this one. Can somebody give me another reason why you know this point doesn't work based on this? Go.
So from the 18 to 15, it's decreasing instead of increasing.
So Oakley's looking right here.
Yeah.
The graph of G itself is supposed to go up, meaning the y values on G have to go up. The y values went from 12 to 18 down to 15, that's violating this
Yeah.
requirement. 3 tickets. Anybody have a question? Wave if you want me to keep going. Don't wave if you are content. You want me to keep doing it? Keep going a little bit?
Are you just
All right,
gonna
please.
keep going though with all the points?
Yeah, you
Like-
basically just keep testing them.
Okay.
So like if we go to this one, Chad, we won't write it all out now because it gets a little bit tedious. The point we're here, 6, 18, Chad, what would the secant slope here be?
0.
0. So secant slope of 6 to 0, that doesn't work either. Nor does it work to go from 12 to 18 to 18. So go to the next one, 21. Let's see, that's 6, 21. Similar problem. I have a secant slope of 6 and a secant slope of 3.
Oh, just real fast, why do we know that the secant slope has to constantly be increasing? Is that because it's concave up?
Yes, perfect. If a graph is concave up, then you know as you read the graph and you go from secant to secant to secant, must have an increasing sequence. Perfect. Please,
Okay,
Justin.
I did a lot faster and so I'll make sure I'm not doing it wrong.
You're good.
So I just looked at it and saw that from 12 to 18, it was increasing by 6. And then, so I thought it needed to, because then I used like Danica's chart and I knew it needed to add more than 6. So it like crossed off A through C, so it's between D and E, but then it needed to increase more than 6, so 27 is only worked.
No, 3 points for Kelsey. Listen to what she's saying. You have to be a little careful about one thing. You gotta make sure you're paying attention to how much X is changing as well. Because it could fool you by going like from 4 to 5 to 7, and then your method would be, you have to just be careful, but otherwise it's perfect. Because what you're paying attention to is the fact that if a curve is concave up, that means as you go from point to point across the graph, it's got to increase more and more. No, that's perfectly fine. Anybody else? Ellie? Cool. Now let's have a different question from the gold pathway. Cool. 15 minutes to go. I'll just kind of walk around, and if you're working on the green or the gold, you can just ask me individual questions.